Hello everyone, it's January 18th. Alright, back at it. Yeah, evening has its benefits. It's just more chill. I think the mind is as sharp as in the morning, because the first thing in the morning, the mind is actually not that sharp. I'm still kind of sleepy. And now I got a little bit sleepy, but it's good enough. Alright, let's do this. Minimum falling path sum. Given n by n array of integers. Return the minimum sum of any falling path through. What does it mean by falling path? Start at any element in the first row and choose the element in the next row that is either directly below or diagonally left to right. Specifically, the next element from position row column will be row plus 1, column minus 1, row plus 1, column row plus 1. Okay, so anyone will get these three. So that's a falling path. And we want to find the minimum sum of any falling path. Interesting. Okay. Maybe let's start with DP. Right. So we have a 3 by 3 matrix. So 2, 1, 3, 6, 5, 4, and 7, 8, 9. All right. Really? It's DP? Anyway, so we're gonna go from this towards the bottom, right? So for 2, we have these options. Oh yeah, because for 2, I can go to here and here. For 1, I can go to here, here, here. For 3, I can go to here, here. And then, yeah, it's just the minimum, right? The minimum. So we can start from the bottom when they say the minimum to reach these are 7, 8, 9, and then we can go backwards. Exactly, can go backwards. So who can go to 7? So 6 and 5 can go to 7. So reach here is minimum is this. So from this going down, right? The minimum is going to be so I will say we have something like this. It's like a DP, right? The bottom is just going to be A7, A9. And then the next level is this. So for 7, I can update 6 and 5. So this will be 13. This will be 12. For 8, it's going to do these 3. So this will be 14, 13, 12. For 9, it's going to be 9, I cannot do this. 14, 13. So okay, this level is these 3. So the minimums are this going down. And then the top was going to be, first one will go, it's 13, right? So it's 15 and 14. And for this is going to be 14. Oh, that's going to be 14 and 13. And then this one is 15. And for here is 15. No. 13 again and 15. So the smallest value is going to be 13. And we start from where? Starts at any element in the first row. Any elements in the first row. So okay, so can we do this with 1? Because the first one, I update this, no, I cannot. I think we need 2. Okay. We have a solution. Too much. Oh, I just realized I didn't really code anything today. Mostly today was just testing, bug fixes, stuff like that. Okay, so here's what we're gonna do. We're gonna say DP is gonna be matrix, right? Matrix minus 1. That's the DP. And we're gonna say for I range len matrix, right? Len matrix minus 2, right, to the first one. Temp is gonna be 0. Ooh, we need to find the minimum, right? So we need a large value. Large value. I'll do math.inf times n by n. Let's do this. N equal to line matrix. Okay, and then here we can change that to n, and then this is gonna be n. Okay, so temp equal to this, and then we're gonna say for I in for j in range n, right? For each thing, next j. Okay, for dj, right, in range in, so it is -1. Oh, you know what? I don't like it. I think this one will be better to j. No, this is I. My bad. This is I. This is j. For dj, so we'll go -1, 0 or 1, right? And nj shall equal to j plus dj, right? J plus dj. If nj is, nah, I feel like this is that's okay. Now it's only 3, right? Maybe it'll be easier. We just say if j is larger than 0, right? Then temp j -1 equal to minimum temp j -1 and dpj plus matrix I, right? I plus, no, that's it. Right, temp is the one above you, so we're gonna hit j -1 is gonna be dpj plus whatever value is in matrix. Oh, matrix I, that's wrong. Matrix I is the current row, and then j -1, right? So that's that. If j larger than 0, and then temp j shall equal to minimum, same thing, temp j dpj plus matrix I and j. If j is smaller than n -1, then temp j plus 1 equal to minimum temp j plus 1 and dp j plus matrix I j plus 1. So no, 3dd. There we go. Okay, so that's that. We handled everything. So once we handle everything, dp shall equal to temp, and now we keep going, and now we'll return the minimum of dp. Okay, that's the solution we're gonna try. Yep, I think it's correct. I'm confident. We should write some comments for this. Let's do it here. So LeetCode 931. Use dp and bfs. Let's call that, right? O(n) squared. It's not too hard a problem. Have you tested any edge cases? Honestly, no, I have not. But maybe it's fine. What's the edge case? N at least 1. Okay, so we test one edge case. That is an edge case, right? So it's just one row, but it should be fine because we don't do this. Oh my goodness, that's true. Because it's the n by n. Yeah. Alright, we'll go with this. And wait a second, how is it so much faster than the last time? Was it 49 test cases? 50 test cases. Ah. Because I did plus equal to minimum. Oh, yeah, that is true. We always want to find a minimum. Really? We always try to find a minimum. Matrix I, J shall plus equal to the previous. The minimum of the previous. That is actually true. Right, so we have the minimum of the previous. Then you keep going, you find the minimum of the previous. I think it's slow because of the slicing thing. Yeah, that's fine. It's the same idea. Okay, so that one's good. We're done. And move on. No. I can take a look at this. Let's solve this one first. Split strings by separator. Given an array of string words and a character separator. Split each string words by return an array of strings containing the new strings formed after the splits, excluding empty. Separator is used to determine where the split should occur, but it is not included as part of the resulting string. A split may result in more than 2 strings. Oh. Do we have flat map in Python? I mean, we don't need flat map in Python. I mean, I don't even want to put this one here. But, you know, just for the case of completeness, and it's always better to practice, you know, practice all the key bindings and stuff. I feel like I'm already a lot better than when I first started with Vim. So anyway, this one shall return. Anyway, it's gonna be 4 W in words, right? Oh, we do the chain. Hold on, that's actually interesting. From Iter tools for the chain. Actually, I forgot how chain works, but we can give it a shot. We can say chain words dot split separator. I'm actually not sure if it's even correct. And then we're gonna have to list this whole thing. Oh, my bad. It's not right. It should be word. Okay. I don't know. Is it right? Nope. Let me think. So, maybe this. Yes. In the chain, something you need to put that into each argument. Oh. What the hell? Oh, empty string. Holy crap. All right, so more. All right, for s in if s. I forgot, it does say no empty string. Yep. Okay, note that we have to check whether the string is empty and not included in the answer. Okay, that was good. Problem. Next. All right, minimum difficulty of job schedule. You want a schedule, a list of jobs in D days. Jobs are dependent. To work the ith job, you have to finish all jobs J, where J is in front of you. You have to finish at least one task every day. The difficulty of job schedule is the sum of difficulties each day of the D days. The difficulty of a day is the maximum difficulty of a job done on that day. So the difficulty of job schedule is the sum of all the difficulties of each day, but difficulty of a day is the maximum job on that day. You're given an array integer job difficulty and an integer D. The difficulty of the ith job is that. Return the minimum difficulty of a job schedule. If you cannot find a schedule for jobs, return -1. Okay, so basically, we have a list of job difficulties, and to do each job, you have to finish all the previous jobs, right? Therefore, you are splitting. Yeah, I remember this one. So therefore, what you're doing is you have a list. You have 6, 5, 4, 3, 2, 1. You know, split it into these sub arrays. And the question is to ask, how do you split it to make it the minimum, right? And I remember my solution was dp, right? So it's going to be dp from an index and then the remaining number of days. So we're starting from here, right? If we're starting from here is the new split, right? And we have minimum number of days. So what's the minimum? So the answer shall be dp start from 0 with d days. That's the answer. So for each one, we can say, okay, I start from this job. I start take as much as I can, right? Yeah. But it's the same solution as the other one. Okay, let's go back. 3, 5. Wait, hold a second. Do we have 1, 3, 3, 5? No, we do not. Therefore, we can copy to 1, 3, 3, 5. Right. Then we'll cancel all that. Okay, so we're gonna do def dp index remaining oh no, from func tools import cache cache at cache max size is none, right? So this one, again, if index is, hold a second, when n equal to land job difficulty, right? So what's the ideal scenario? So if index because this is the last. So the ideal scenario is when index is equal to n and the rem is equal to 0. That's the ideal scenario. That, right? That's the last. That was just return 0, right? That's return 0, the last day. Now, otherwise, if remaining is 0, the index is not at the end. So we have some day that we cannot do, right? So we, yeah, so that's an impossible case. Or remaining is smaller. So if remaining is smaller equal to 0, that is an impossible case. So we shall return math.infinite. Another impossible case is we have remain, but we run out of days. So we run out of the days. Or we run out of jobs. We still have days left. So that's when you say or index is equal to n, right? So if remaining is smaller than 0, index is not equal to n, right? Or remaining is larger than 0, so we still have days remain, but index is already n. So both of these are impossible cases. So other cases I think are possible. So what we're gonna do is we start from index and then we just try. And now as we try, we keep track of the max value, right? Because the max value has become the job difficulty. So what we're gonna do is res is equal to math.infinite, and then we say for I range, index towards n, current difficulty is going to be 0, and then we say current is equal to maximum current job difficulty, right? Job difficulty I, right? That's the current. And then we say, okay, that's it. Then res shall equal to minimum res, and the current is the current job difficulty plus dp, because we include I, so I plus 1, and then remain minus 1. Right? And we have to take each day, have to take at least one job, right? At least one task every day, which means we cannot skip. There's no partition of skipping. So yeah, so each partition you just start from the first one, right? You take it, and then you say, okay, I only do 1, or you do 2, or you do 3, or you do 4. You just keep going. So we do that, and then at the end we'll return the res, and we'll run dp. We just return, right? dp starting from 0 with d-day left. Okay, I can run some test cases here. So I have 6, 5, 4, 3, 2, 1 with 2 days. The answer should be 7. Next one is 9, 9, 9 with d is 4. It's minus 1. Ooh, I didn't have that. So what do I do? Res equal to dp0d, and we shall return res if res is smaller than math.inf, else return minus 1. I forgot about the minus 1 situation. And third one is 1, 1, 1, and d is 3. The answer is 3. Okay, So we have 2 job difficulty first, difficulty D, main difficulty, job difficulty D. Okay. Let's run here. 3. This one is 1, 3, 3, 5. Okay, I think this is correct. 33K. Yeah, it's fairly straightforward, DP, but I remember this one has a different solution. Right? It's not that bad. Last time I think it's 1 attempt as well, but there is a better solution. There is a better solution, but I don't think I remember what that better solution is. So this is the DP, right? This is the DP solution. This is the DP solution, and ND, right? That's that. All right. So the question is, what is the other solution? I don't remember. Let's look at a hint. Oh, n squared. My bad. Yes, it's n squared. Shoot. I don't know how you forgot it's n squared. N squared. The reason it's n squared because this is nd, and then within it you have to run n times as well. So that's why n squared d. Wow. Okay. So what is the other one? The other one I remember is OND, right? OND. No, I remember it's OND. I don't remember how it's done. Completely blanked out. We have some hints on the other one. Don't read the solution, read this faster. Represents the minimum difficulty ending with I number of subarrays. Okay, that's the same. But we don't go through the whole thing. That's what I guess. 1 DDP and 2 DP arrays. Huh? The real trick to make this solution, okay, it's 1D DP. Can you do 1D? Yeah, and I guess I can do 1D DP on this one. Because each time you just go through the whole list and you try to find the maximum. So you know what? We shall write this in bottom up, right? How do we write this bottom up? So basically we have, yeah, usually this problem bottom up will help. Right, we have, again, 6, 5, 4, 3, 2, 1. If we do bottom up, what we want to know is the same thing, right? So we can, it's a dpij, right? From I towards the end with j days left. What is the smallest, right? And then to know, like if I know all the ij and I give me a new ij, what I need to do is, we're on I, right? So what we need to do is, it's probably not, maybe ending at I, right? Maybe that would be easier to know. Ending at I, so we go this way. Ending at I with ending at I with j days left, right? So what we want to know is dp, n minus 1 with D days left, right? That's what we want to know. Okay. So with I days, no, I, ending at I with J days left, okay? So I can see this is the ith row, okay? This is the ith row. And then we'll have J days left. So if we have 0 days left, 0 days left, maybe we need to go back to front. What do you think? Yeah, we need to go back to front. So this is the n minus 1th row, right? So in this case, this is the 0, 1, 2, 3, 4, 5, the 5th row, okay? 5th row with 0 days left. Well, you are here with 0 days left. Oh, actually, there is a 6th row, right? And the 6th row with 0 days left, that's 0, right? Otherwise, if you still have some days left, that's infinite, right? In this case, D is 2, so it's a 0 day left, 1 day left, 2 day left, okay? Now we go to the 5th row, which is this, okay? And this, if you have 0 days left, right? If you have 0 days left, you're on this, but still there, that is infinite, right? That's infinite. If you have 1 day left, right? If you have 1 day left, then you can say, I take this day, right? I take this day, and then if I take this day, then what I need to find is the next one with this, right? So this one will be 1. And then this is, we have 2 days left, right? We have 2 days left, and we have to take this day, right? We take this day, and then the next one's gonna be 1 day left. That's an infinite, so that's gonna be infinite. So that's 5th row. Okay, 4th row. So the 4th row, that's too big. The 4th row always start with, that's an infinite, right? And then we're here. And then we say, okay, so we do this, right? 2, and then we try to find, so we take this by itself, and the next one will be 1. The D minus will be 1. So it'll be 1, right? So this will be 3. Or I can extend to 1, right? So what we need to find is the maximum value in this. So at each one, we need to find the maximum value. Starting from here, I need to find a max value inside this whole thing. No, not the max value, like as I go through. Nah, that doesn't make any sense, because you have to go through the whole thing. What we're trying to say is you don't go through the whole thing. This is not the best way to explain this, isn't it? So what would you think? Because as you keep going, right, as you keep going, the max value, yeah, you find the max value so far, and then you add to the next one. So if you know where the max value, actually I don't know. I have no idea. I think I'm actually making it worse. All right, let's take a look. Oh. Oh. I think I might remember what this one is. Oh, it's a very complex thing. Very complex. Extremely complex. Yeah, it's some, oh my god. I think I remember this. The other for I minus 1, we call it dp. The real trick to make solutions that we use a monotonic decreasing stack to speed up the check from job difficulty J back to, so this one is go backwards, which is fine. Yeah, you can do backwards from current, just go back to a certain point, you find a maximum and you get that. If all the values between some job difficulty K to J, which is the current one, right, are smaller or equal to all the job difficulty J, then as we go from J to K, the difficulty of the subarray does not change and it remains job. Yes. Therefore, if we use a monotonic decreasing array for all the job difficulty on the left, we only need to compare with very few of them, since all the other job difficulty will be smaller than the ones in the stack. Okay, but you are also missing, right? Because each time you go, didn't you also can add? But it's this line. Temp K minus job difficulty K plus job difficulty J. Once we encounter some job difficulty K that is bigger than job difficulty J, the current difficulty will be the same as the difficulty of the previous difficulty already computed. Then we continue with the stack. Oh, what the hell? So we start with this. We create I to maximum dp. Wait, what the hell is this? Oh, it's 1 day, right? It's just 1 day. 1 day if I do day 1 ending at, okay, day 1 ending at I, it's just gonna be keep yes. And now this is day 2 all the way to this. And for each one I set up a stack. And then this is day 2. Everybody will be maximum. And then we're gonna go, yeah, this doesn't matter. So this is just day 2. Yeah, day 2 because you're the second day. Day 1 at least has to have 1, so the smallest to go from this to this, okay. So temp J, is J equal to 0? Which is the first one, right? If J equal to 0, will be 0 plus job difficulty. So, okay, here, dp J minus 1, that's the previous, right? That's the dp J minus 1 is the previous. Previous ending at J minus 1. So this is, we take the job J by itself, right? So that's the starting point. And then we are going through the stack. Okay, job difficulty stack though. Peak, we put the index in it, okay? If it's smaller because it's a monotonic decreasing array, so we just start popping them. And each time we pop, we can compute its. I remember there are like a complex way to compute this, to prove that this is correct. Okay, at the end, if stack is not empty, if stack is empty, that means the current job difficulty is the highest. It's the highest job difficulty, which means the there's nothing. We already handled all the j, right? So if we still have something, then we say it's gonna be the temp. What? Temp stack.peak. Temp stack.peak is the. Oh my goodness, I still don't understand. So basically, as we go through, we put a monotonic decreasing array. Okay, that I can get behind. And every time when I have my current job, and then if I have some values who's smaller than me, then as I go through, the current day's job difficulty does not change. It does not change. It will only change if I hit some value that's bigger than me. This is what this one does, right? And once I hit some value that's bigger than me, and if I'm included, then my job difficulty of this current day will be the same as the value bigger than me, which means the difficulty of the current day ending at current day ending at me, that j, will be the same because everybody is smaller than the previous one, and it's, because we hit that one. So yes, okay, this one makes sense. I can understand this one. All right, so I have to go back to this. Can you prove it? Okay, so this is not right. Okay, we don't go this way. We trying to say dpi j, right, is the ith day, right, ending at j. That's what we're looking for. Ith day ending at j. And then we have a monotonic decreasing array. Like we have a monotonic decreasing array. And then now we have a job difficulty j, which is bigger than this, right? That which means we'll pop this, and everything in between is also smaller, which is fine, right? Which actually I'm not sure. This is something I need to prove, right? I need to prove. I don't remember the proof. Because as I go through this, right? As I go through this, if I like group these together, right? If I group these together, then the current difficulty is going to be job j, right? So difficulty job j, and then we'll have the previous difficulty. So yeah, it's going to be job j plus the previous difficulty is going to be the dp, right? I don't see any dp here, so that doesn't sound right. That doesn't sound right. Oh, I forgot. I need to check again. go to, I have to copy. Yeah, that's why this problem is still here. This problem is still here because of this the difficulty of understanding. It's this one, right? Okay. Yeah, I even left a message, but the algorithm can ignore these wrong answers automatically. There are two situations. Okay, let's see. If dp2i is larger than wait, what the hell is I? Wait, hold on. I think we have different notations. This is his I. This is his J. Okay. So dp2i is, okay, I know what dp2i is minimum. dp2i, that's fine. dp2j is the k thing, right? I mean that dp2j does not take aj as today's difficulty. There must be a, if dp2j does not take aj as today's, then there must be a ak larger than this, where this, yes, and what the hell is this? And dp2j what equal to dp2j, that's correct. Yes, that's correct. Okay, so we say if ak is smaller or equal to some k value, right? If it's smaller or equal to ai, dp2i, these two are equal because dp2i is j is equal to, wait, hold on, what's j again? What the hell is j? aj is today's difficulty for dp2j. dp2j minus aj and plus ai, because ai is the current day's difficulty, and then we say dp2j minus aj will be the previous day's difficulty, but there's no guarantee. Okay, if dp2j does not take aj as today's difficulty, there must be ak larger than aj, where this, okay, so if ak is smaller or equal to ai, so we have some ak is big and the j is small, and then ai is even bigger. So if that's the case, then dp2i minus aj plus ai shall equal to dp2k, because dp2j and dp2k is the same. Yeah, if dp2i is, like, if aj is the larger, aj is the maximum, then dp2j minus this aj. Because ai is all the way leading to j, right? And then what we need to do is to find the smallest wait, hold a second. Minus aj is from I to j, not including j, right? From I to j, we have a certain thing, and then ai is bigger than this, so it's going to be ai for the entire thing. And if aj is the difficulty of the data ending at aj, right? And then aj, which is biggest of that subarray, then if we remove aj, right? Because we hit to aj, we want to know what's the previous one. So it's just going to be dp2j minus aj. That will be the previous one. So, okay, that makes sense. So if aj is the biggest, then we're good. But now we have an issue where aj might not be the biggest. If aj is not the biggest, then there must be an ak, which is larger than aj. Okay, so now if this ak is smaller than the current ai, then this satisfies, which is correct, because dp2j is equal to dp2k, right? It will be equal because ak is larger than aj, which means as we keep extending, it will be the same. Yeah, because if not, if you break out a new one, then it doesn't make any sense. It could be smaller. Yeah, so they still the same, and ak is larger than aj, which means dp2k minus aj, this is larger than minus ak. That's correct, right? Minus aj plus, thus dp2k minus aj plus will always be ignored after k is processed. So this wrong answer will be ignored after k is processed. That's right. Now if ak is larger than, so we have even a bigger one, then we had this. And dp2i is dp2i minus this is dp2k minus this, right? Smaller equal to ai. Wait, hold a second. What is the last one? It's dp2k, right? And dp2i, right hand side, equal to dp2j minus aj plus ai. dp2i equals dp2j minus aj with equal to dp2k minus aj plus ai. dp2i is larger equal to dp2 stack. Huh? The last part I'm not able to understand. AK is larger than AI, right? AK is larger than AI. Then, I mean, AK is larger than AI. We try to prove that all the answers in between can be ignored. Okay, so in the middle we have all these values. What is this? dp2i. dp2i equal to dp2j minus aj plus ai. I think this is say if we keep using the wrong answer, because we know these answers are wrong. Right, so we're using the wrong answers. aj is smaller or equal to ai, then dp2i shall be larger or equal to, because aj is smaller or equal to ai, so this value is larger than dp this. So the wrong answer is larger than this. Thus dp2i equals this equals dp2k. Okay, I think I understand. So basically this is saying if we take whatever a wrong answer, this is the wrong answer. If we take the wrong answer, it will equal to this. And because aj is larger than aj is smaller than ai, so this value is bigger than dp2k, which means at the end when we compare, find the minimum of these two, any time of this dp2i becomes sum of this will be bigger than this, so it will not be affected. Oh, dear me. Dear me. It is not possible. No. Not possible. Oh my god. Alright. Yeah. Maybe we can try to implement it yesterday. Not yesterday, tomorrow. But this one will stay here for a very long time. Very, very long time. Dude, it's so hard. This one is so hard. So hard. The easy method is, the easy method is easy. Simple DP, right? But to get to that on times d is a whole different story. Whole different story. I'm not doing that today. Not doing that today. I'll do it some other time. But once I'm done, this has to move to the bottom. Move to the right. Oh, this we have to I have to redo this one again. We have to redo this one again. Ugh. Maybe I can do this. Yes, I still remember the solution for this. And this is just God. I haven't even taken a look at this yet. Alright, anyway, that will be it for today. I will see you guys tomorrow.